Hello everybody, this is Mark Applegate with Innovative Utility Solutions, and I'd like to take just a quick moment to have a conversation about flushable wipes. Specifically, flushable wipes and or baby wipes, sewage grinders, and how these two things just don't always work out so well with each other. Now, if you're watching this video and you're in the field, you know there's a lot more things that you'll find in your sewage system that aren't supposed to be there other than just wipes. But wipes have been quite the topic of a lot of conversation lately. And in fact, if you're watching this video, more than likely scenes like this have been a part of your everyday life for years. So you know that the problem occurs whenever the grinder is part of the way through chewing up some debris when the water level drops in the tank. The float switch drops, kills the power to the grinder, and the grinder is left with debris stuck in it. So then whenever the water level does come back up, the grinder tries to kick back on, but it just can't generate the amount of torque required to overcome that clog. So then field personnel are sent out to the lift station, pull the grinder, clear the clog, and then it is once again operational. But now that's the problem. You all know all about it. Rather than spend any more time talking about that, I'd really rather talk to you about a solution. And that solution is the float management control from Innovative Utility Solutions. The float management control box protects against clogs by recognizing when pump grinders are working harder than normal to chew up debris. When a grinder is chewing through tough debris, it draws a higher amount of current than it would under a normal continuous load. The float management control box sees that the grinder is having to work harder, and it will effectively override the float switch and keep the grinder running until it sees that the grinder has chewed up the debris and is back to operating at a normal load. This test will illustrate what I am saying. In this test, we are feeding a sock into this 2 horsepower grinder. Quickly, the float switch is lowered, simulating that the water level in the tank has dropped to a level where the grinder would typically stop functioning. Now, if it were to quit now, it would be clogged by a sock the next time it tried to turn on, and it would not be able to generate the torque required to start turning. This would trip the circuit, and the grinder would be unoperational until someone removed the clog. However, the meter shows us that the grinder is working hard to chew up that sock. Therefore, the installed float management control box will keep the grinder operating until the current draw of the grinder indicates that it has returned to a normal working load. In this test, we fed 2 tampons into the grinder to test the float management control. As long as the float is down when the grinder returns to a normal working load, the control box will let the grinder shut down as normal, and we are left with a grinder that is clean and ready to keep on working where it would have otherwise been locked up. This model of float management control can be used on pump grinders that require up to a 40 amp draw on a normal continuous load, as the maximum amount of current that it can measure is 50 amps. However, custom models can be ordered to meet heavier demands. These control boxes are available in single or 2 channel setups to work with single or multiple pump systems, making a good fit available for residential or commercial use. Also, these boxes are proudly made right here in the USA. And one more important note, installation of the float management control is very quick and simple. Most units can be installed in as little as 15 minutes, but the unit must be installed by a qualified, licensed electrician, as the power coming into these panels is sufficient to cause serious injury or death if proper precautions are not taken. Power to the panel must be disconnected before installation. First, we'll find an area in the panel with enough clearance to mount the box. The box is small, so not a lot of clearance is needed. Now, while there may be a large number of components in the panel, there are only a few of them that we will need to work with, and we will look at those components in the diagram to the left. At the bottom of the diagram, you'll see the float management control box from Innovative Utility Solutions with 5 wires exiting the bottom of the box. 1 gray wire, 2 black wires labeled for motor 1, and 2 black wires labeled for motor 2. To wire in the new control box, we will remove the grinder pump hot black wires from the terminal block inside the panel. Use a wire nut to connect the black grinder pump wire to one of the appropriately labeled black wires coming from the float management control box. Connect the other appropriately labeled black control box wire to the terminal block where you previously disconnected the black grinder pump wire. The gray wire has 4 smaller wires inside of it when the gray jacket is pulled back. Now we will run the gray wire to make the rest of the connections. On some panels, you may have a control board that clearly indicates where each float is connected, in which case you'll only have to determine which is the constant hot lead. In some other panels, such as this one, you may have a DIN rail mounted terminal block, in which case you may have to remove the offload from the tank to identify where it is connected to the panel. With the offload identified, we'll make the rest of our connection. The smaller black coated wire coming from the gray jacketed cable will be tied in parallel with the offload wire that is receiving constant voltage. The red wire coming from the gray jacketed cable will be tied in parallel with the off-float return wire that only receives voltage when the float is in the upright position and the float circuit switch is closed. The white coated wire will be connected to the neutral post in the panel. Ideally, the white wire will be run to a neutral wiring block if one is located near the float connections, but in this example you'll see that we are tying the white wire in with the neutral post of our alternating relay. Finally, the green wire will be grounded to the inside of the panel. Once all connections have been made, double check the labels attached to the float management control box wires and make sure that all connections have been made correctly. After the control box has been installed and power has been restored to the system, we will set the box to recognize what a normal load looks like for the grinder that it's hooked up to. With enough water in the tank to keep the grinder submerged during calibration, we will turn on the grinder and make sure that it is pumping water and not trying to chew up any debris. Remove the rubber plug from the box that is located below the identifier for the grinder that you want to calibrate to. Follow the instructions included with the unit to calibrate the box to work with the grinder. Once complete, replace the plug to keep a weather-resistant seal. These control boxes can be moved to different size grinders, but the calibration must be repeated anytime it is hooked up to a different unit. Once calibrated, the LED will illuminate anytime the control box is keeping the grinder from shutting down due to a heavy load on the grinder. After the control box has been installed and calibrated, you can walk away from it and be confident that you'll be returning less often for maintenance. So there you have it, guys. That is the float management control from Innovative Utility Solutions. Guys, I just want to thank you for giving us a moment of your time to watch this video. If you have any questions about anything you saw, please feel free to get a hold of us. We will put our contact information at the end of this video. Obviously, we're very excited about this new product, so we would love to talk to you about it. In the meantime, from our family to yours, be blessed and be safe.